Hello, and welcome to this second video on chemical analysis aimed at National 4, National 5 level. Okay, in the last video we saw that chemical analysis is carried out for a variety of reasons. Maybe checking pollution levels, or in forensics, or analysing the contents of minerals, that sort of thing. We said that qualitative analysis is about identifying what substances you've got. We compared that with quantitative analysis, which is about measuring how much of a substance you've got. Now, in the last video we saw 3 tests for gases. We saw the test for hydrogen, for oxygen and for carbon dioxide. And in all those we started with test tubes of gases. So it's useful to know how we collect those gases in the test tube. There's basically 2 ways of doing it. One is by displacement of air. Now, before you carry these out, you're going to need to know the formula mass of the gas you're collecting. You need to know if the formula mass is greater than 28 or less than 28. Why 28, you may be asking? Because in gases, the density of the gas is directly related to the formula mass. So, gases with a density of more than 28 are denser than air because most of the air is nitrogen and the formula mass of nitrogen is 28. So gases with a formula mass bigger than 28, bigger than nitrogen, are denser than nitrogen. So we'll treat them as denser than air. Similarly, gases with a formula mass less than 28 are less dense than air. And the only real difference is how we hold the test tube. If it's denser than air, you hold the test tube that way up. Less dense than air, you hold it that way up. Let's look at why. Let's bring in a couple of delivery tubes, and you've got to assume the gas is being produced maybe in a chemical reaction on the left hand side here and on the right hand side there. Okay, let's look over to the left for a gas that's denser than air. In it comes, down the tube, and because it's denser than air, it will stay at the bottom. It will sink to the bottom of the test tube and push the air up and out. We call this upward displacement of air because the air is being pushed up and out. And the gas, being denser than air, sinks to the bottom of the test tube. Compare that with the right-hand side now. This is a gas less dense than air. In it comes, it'll rise up there, and because it's less dense than air, it'll stay at the top of the test tube and fill the test tube from the top. Again, this time pushing the air down and out. So we call this downward displacement of air. Okay, so this is in many ways the simplest way of collecting gases. I should point out, however, gases are rarely coloured. I've coloured these gases yellow and pink simply so that you can see them. A lot of the time gases are colourless and you can't see them. So the downside of this method is you don't really know if the test tubes are full or not. If you want to know if the test tube's full, you could use displacement of water. Now this only works for some gases. I'll come back to that. But this is a bit more complicated. You get a beaker and you fill it with water. Yeah, again, I've coloured the water green so you can see it. If your water is green, don't use it. Okay? But the green stuff here is the water. And we'll bring in a delivery tube that looks like that. Now you want a test tube. You fill the test tube with water, turn it up and put a stopper in. Then you turn it upside down in the water like that and take the stopper off. That way the water stays in the test tube. Okay, let's bring in a gas from the left hand side now. There it goes. This time the gas is kind of white in colour. Of course in real life you wouldn't be able to see it, but up it goes, and now you can see it because it'll start to make bubbles, and those bubbles will rise to the top of the test tube, and as they fill the test tube they'll push the water down and out, like that. So the water is displaced and pushed out by the gas as it fills the test tube. Now, what's really useful about this is if instead of just a test tube, you use something that's got measurements on, you can actually measure how much gas is produced. We're verging now into quantitative analysis. We're measuring how much gas is produced. The only difficulty with this method is that the gas must be insoluble in water for fairly obvious reasons. If you pass sulfur dioxide or ammonia into water, it will just dissolve and it won't fill the test tube. If you're dealing with a gas that is soluble in water, or indeed any gas, you can use a gas syringe to measure how much you've got. Now, a gas syringe looks like that. Okay, we're going to look at how we use it now. Notice the measurements up the side though. These are measurements of volume. Okay, so what do? Let's get a flask, okay? Let's assume we're going to do a reaction that generates a gas. We're going to bring in our gas syringe. Right, we're going to attach it to the side arm of the flask there, usually with a little bit of rubber tube. Now, you don't want to leave it just like that. You're going to want to put a clamp on that to hold the gas syringe in that position there. So you put a clamp there. I'm not going to draw it in, but that's where you put your clamp to hold the gas syringe horizontally. Now you add your reactant and put a stopper on. Now we said that this is a reaction that creates a gas. So there it goes, it produces a gas. And as that gas is produced, it will force the syringe out like that. And then you just measure off the volume on the scale on the syringe. And that tells you the volume of gas produced. Okay, so to sum up, gases can be collected by displacement of air. To do this though, you need to know the density of the gas you're collecting. You use downward displacement of air if the gas is less dense than air, because that will fill the test tube from the top and push the gas down and out. For upward displacement of air, you use gases that are more dense than air, because they will sink to the bottom of the test tube and fill the test tube from the bottom. Insoluble gases can be collected using displacement of water, which works in much the same way. Notice though, they have to be insoluble, otherwise they will just dissolve in the water. But you can use this method to measure volumes of gas if you use a graduated container, maybe something like a measuring cylinder, to collect the gas. Any gas though, the volume of any gas can be measured using a gas syringe. Okay, that's it for now. Thanks for watching. Bye just now.